This conference will now be recorded.
There you go. All right. So one of the things was the thick host says, "Hey, I have you have 100 gigs of storage. I see 100 gigs of storage versus your thin provisioning that you have inside of the Stratus with the VDO, and we're going to get into that later on. It allows you to say, hey, I have 100 gigs. I know I have 100 gigs, but me, the actual host in terms of in terms of the virtual host. And when I say virtual host, let me find my mouse. Virtual host, I mean this virtual host here. I only see 100 gigs, and I'm only allowed to use 100 gigs. But it may be it may be 1 terabyte, but I only see 100 gigs. And here's the reason for thin provisioning. It is just like this. So I I take that 100 gigs and I issue that, right? And the person or the group of people who are using that particular VM only use say 8 gigs of that 100 gigs. Well, I just got that 92 gigs or 92 minus 5% of hard drive just sitting there not doing anything. So I'm wasting storage at that point where that storage could be used somewhere else. So that's what these chapters are talking about: thin provisioning, thick provisioning, KVM, LVM, NFS, all storage space. This is really about storage and how to handle storage and tuning and security. That's what the 134 is about. It gets into how to handle your storage, how to handle uh, uh, processes, how do you get yourself out of a bind if you mess up your boot record. What are containers? How to use Podman, how Podman is related to Docker. That's what this chapter gets into. Your basics that you need for Linux. Then when you roll into your RHCE, we start getting into Ansible and how do you manage and configure something in an automated fashion. We're gonna use GitLab, or we may use GitHub Actions. Um, and I'll probably just kick off some little machines in with Terraform, give you a template of that, and then you can start configuring your machines, like how we use for loops to create, say, 6 usernames or 6 users on a machine. We can use Ansible to do that for us and manage that. Because now, if I did it from command line, I have no way of knowing what you did from command line unless I go to the history or you put inside of some type of documentation of what you did. But if I do configuration as code, I can now manage what you actually did. I can see what you actually did. I can go back and make changes. I'm able to control the environment more. So that's what we want to get into. Anything that we do manual, we want to be able to automate it. That's the goal. We want to always be thinking, oh, I did that manual, now I need to automate it, right? So we always want to be in the mode of automation. All right. Any questions so far?
I got a question.
Uh-huh.
So at my job, they always say use thin provision because it's better.
Mm-hmm.
Um,
Yeah.
but I
Yes.
never really got that concept, even
Yeah.
even the
That's what I was just explaining. Like, you have thin provisioning. I got 100 gigs of of storage sitting here, and I give a machine all the 100 gigs. Well, I got 4 more machines that need storage. Why can't those other 4 machines, if I'm only using 8 gigs on one, I then provision that 100 gigs out, and then all the machines can use it, and I don't have wasted storage sitting there. So let's go.
okay.
I don't know if you ever did this. So you can do thin provisioning versus thick right here, and it's very clear when in VMware when they do it. Let's go here, VMware, because VMware uses that a lot. Let me see. I don't want to use that one. Here we go. Hopefully this is a good one. No, I don't want to read somebody else's definition. Here we go. It's from 2014. So thin provision versus lazy thick provision versus eager thick provision. But anyway, let's get into it. Let me blow this up a little bit. All right, so here, um, thick provision has all the space allocated at creation time. So I got 100 gigs, I create that whole 100 gigs, and a group comes along and they only use 10 gigs of it. So I have all this other space just sitting there not doing anything. Versus if I thin provision, the space required for thin provision, the virtual disk is allocated and 0 on demand. So basically, I get space on demand. So if I decide to grow, then I grow.
Okay.
Got it? That makes sense?
Yeah. Yeah.
All right. All right, so let's go back here. All right, so Rev, or Red Hat Virtualization, provides a centralized web interface to allow administrators to manage the entire virtual system. So there's a Red Hat hypervisor is tuned to a version of Red Hat Linux dedicated to a single purpose of provisioning and supporting VMs, and then the OpenStack platform is another one. And so then they talk about what operating systems are supported. And this is going to be important because it's on one of the quizzes in here. What operating systems are supported with KVM? So we got Red Hat 6 and up, and then Windows 10. Oh, and FYI, Windows 11 is coming out as well too. And then Windows Server 2016 and later. Then they go into, okay, well, we need to install the tools, and I'm gonna run through this because there's a lab to go through this. They're gonna install the tools. They're gonna use the Yum module to install. With right now they're just listing Virt, and then they'll do Yum module install Virt. And then here's the meat and potatoes of what you need to know right here. And this is for virtualization on an actual hardware machine. Because not if you don't have right now, I think right now in recent years, I think every machine can do virtualization. But if you're not sure, you need to test to see if the machine can do virtualization or if it's enabled. And there are things that you need to do in order to make sure that it is enabled. So right here they talk about KVM requires an Intel processor with Intel VT-X and Intel 64-bit extensions and x86 based systems or AMD. So say you have an operating system installed, right? You can only run this command if the operating system installed. But suppose you don't have the operating system installed. What you would need to do is you would need to get into the BIOS of the system. And once you get into the BIOS of the system, you would need to enable virtualization on that machine. Once you enable virtualization on that machine, and then you go back and reboot and install Red Hat, then it'll have that capability. But even Red Hat will tell you to enable it, and also VMware will tell you to enable it if it's not enabled by default. So that's just a caveat there they don't talk about. But the reason why they're able to run this command is because the operating system is installed. And the reason why you get these passes is because not KVM, but virtualization has been enabled on the system. So once you do that, they go through and they say, we'll do a virt host validate. Again, virt package has to be installed, and that comes from up here. All right, now they give you the one way. Now they give you what I call the cheat way. All right, so everybody likes a GUI here and there, right? So here's the GUI of this. All right, so you have to install, you will have to have Cockpit installed in order to have this serve up on this web browser of HTTPS and that particular machine. and that port will have to be open on 9090. And we're going to get into these firewall rules and so forth as we go on. Anyway, here we are. It says the vert yum module provides the versh command. And I'll show you some stuff that you could check. We've been doing this before, but those that are new would not know this. The Cockpit tool provides a web console interface for KVM management and virtual machine creation. So you could just look here where they have virtual, you could click on virtual machine and it's going to show you the virtual machines that are available. And here we installed Cockpit and it's a service. So we have to enable Cockpit. Remember, when you want something running, there's 2 steps or 1 step. 2 steps is install, or 3 steps. Install the actual package, which is Cockpit dash machines. Then you can do a system enable cockpit.socket, and then you can do a start. This command right here allows you to do those last 2 steps all in 1 step. Basically, you enable it and you start it right now. And so that gives you that advantage. So you don't have to remember those 2 steps. And then it says, now we want to create a virtual machine. And then they walk through here to show you how to create a virtual machine. Where, remember, we have to have some type of ISO for this to boot up off of, right? I mean, to find and install the operating system. So they're giving you an installation source. They're giving you, you're going to provide a name for the vendor, and then the memory, and then the sizing. And then, you can start immediately or not, right? And then, or hit create. And so they go through, you see everything up here. Underneath this is a description of all those things that you see right here in this photo. All right. I won't go through that because I think you can read through that. All right. Then when you get down here, it says create the VM to install to start the operation, and then Cockpit displays the VM console from which you can install the system. And so they then go through and say, okay, well, you can click through here. And remember, we did an install last week, right? We figured out how to use not KVM. We figured out how to create a kickstart, what is inside of a kickstart, what can you do, reboot, the language, the time zone, the pre, the post, whether it should be DHCP enabled or start up off a particular static IP, set the DNS, pick the packages that you want to install. We did all that last week, and Dee should be posting that video as well too. All right, and so that's the summary of that. And then when they have references down here, I would tell you just go ahead and just look at them, look at those references, because they just give you a little bit more insight about the Red Hat KVM enabling virtualization. They talk about that here. And then they also go into some advantages of virtualization. That may be an interview question, like, what's the advantages of virtualization? Why should I use it? Why do I care? Also, Red Hat virtualization solutions. They got, just don't. We went through that already, but they just give you a little summary there, and then getting started. Starting virtual machines, connecting. How do you connect to a virtual machine? How do I get to it? How do I SSH to it? How do I get to the graphical interface? So forth and so on. How do I get to that machine? All right, once you get started. So I implore you to go through the reference that they have down here so you get a better understanding how to manage the system once it's created. So right now, let's go to the lab. First thing, let's go through this quiz, and I think, let me double check here. Is there a lab after this? Yeah, that's a lab. So let's go through this quiz real quick. All right, what 3 operating system does Red Hat KVM support? You should be able to tell me that off the head. Go ahead. What you got?
Microsoft Windows Server 2016 and later.
Mm-hmm.
Okay.
Somebody echoing. I'm reading. Somebody say B. Somebody say E. So I got BEF. Is that what I'm
Whoever's
talking?
talking, go ahead and turn down your speaker for the feedback. Whenever you guys chat, just turn down the speaker because it gives terrible feedback.
So BEF. So no to A, no to C, and no to D. All right, let's show solution. Correct. All right. We just went through it. BEF. All right. So what's the next one? It says which two components are required to configure your system as a virtualization host and manage virtual machines with the web console. Choose two. What do you have? What we got? Angela said A and C. I get a C, so that's we're gonna go with that. And Angela said A. It's only two. We didn't see anything about OpenStack managing, right? We didn't see that. We didn't see anything about KVM module. I don't even think there's a package called Cockpit Virtualization, right? There we go. A and C. All right, next one. Which command verifies that your system supports virtualization? Now it says command. Now I'm gonna give you this tidbit here. It is this. However, I'm gonna give you this. There is a way to use proc, and I don't think it's CPU info. It may be CPU info where you can grep not for KVM, but there's a particular set of things that you're looking for. Let me look up that cat slash proc CPU info virtualization, and only because I had to do it. How to tell if your processor supports this. Yeah, so you want to look for this right here. So you would do an egrep, right, on slash proc CPU info and look for VMX and SVM. But that's not an option that they gave you. But I'm just giving you that in case you ever are in this situation, and you needed to know something different or whatever. But here you go, additional information. All right, show solution. All right, and last one. Which tools can you use to start and stop your virtual machines on a Red Hat system? Well, we know one of them, right? No one. I know one. I'm looking at it. Somebody say E, and what else? C, correct. Versh, right? Remember when you install Vert, remember back up here at the top, well, on the last page, let me go back. On the last page, on the previous page, it said when you install the module for Vert, you also install the Versh command. Your Versh command runs at the command line to start and stop your VMs. All right. So I'm gonna go up here because I can skip over to the lab. Let me see. I'm here. So we did that one. We're here. All right. So is that right? Oh no, that's wrong. Let me go back. Yeah, we did that. Let me get myself together here. 12. We did. Oh yeah, so we did installing the lab. We did that. We'll go back. So we lab installing. So here we did the kickstart. Let me jump down here and make sure that we're not missing out on anything. Yeah, we don't need to do this. This is the lab that you all can do. We did a kickstart last week, so we're finished with 12. I just wanted to show the KVM. Any questions so far before we hop into chapter 6? No? All right. All right, so now we're moving over into chapter 6, and this is basically maintaining, managing storage. What do they mean by that, and so forth. So let me open up my lab environment. Let me go into server A. Let me connect to the console here. Let me see. I know last week we were talking about we couldn't see. But hold on. And the password is student. If I type it right. All right. And let me make this bigger. I don't think I could do that. What did I do last week? Let's go view, zoom in. I did that. Don't like it. I forgot how I made it bigger. If I could make it bigger. Let me do this. And not y'all have to follow along. All right, so here, let's go back to chapter 6, course 6. All right, so now we're talking about the device partitions. And you remember when we were installing on with our Kickstart, we could set up the amount of partitions. We could set up partitions that we wanted, and we could also set up an auto partition, like for it to automatically just create partitions for us. And when you do that, it automatically uses LVM, or you could just create partitions using fdisk or partiq. But we're going to get into that in here in terms of like persistent mounts and so forth, right? So let's hop down here. So we're talking about partitioning disk. All right. So by default, if you look in, let me go into my cloud account. And I need to delete these. And let me go here. Well, better yet, let me go right here. And I'm going to delete one of these. And then I'll delete the second one tonight. So let's delete this guy here. Let's delete. And then let's hop on this interface here. I'm only showing you this so you can understand. I want you to understand the difference between cloud instances and you creating your VMs with your Kickstart, and the different partitions that you would probably automatically see. So whenever my machine connects, so if I just do a df-h, you can see I have 2 partitions here. I think this one was, I added this one here. Let me look. Let me sudo. I think I added that when I was playing around. Let me cat fs tab. Let me see. Did I do that one? No, I didn't do that one. Maybe I did. Let's do an fdisk. It's clear. Let's do an fdisk -l. Yep. So we got UFEI, and then we got a regular file system of 40 gigs. All right. But if you do this a df-h, you can see I have a /dev VM. By default, I believe on the machines that get booted up on your, this is just Google, it'd be different for AWS. It creates these partitions for you. It gives you the most under root of 40 gigs, but you can see the sizing on this and how it's broken out. And as you can look and see, by default, there's no LVM. All right. So I just want to show you that. All right. So if you're ever using cloud instance and running it, if LVM is installed by default, it's not. You will have to create a partition. You will have to add a disk and then use LVM to do that. So here they talk about this partition is necessary and beneficial in situations. Limit available space to application or users, separate operating system programs and files, and create a separate area for memory swapping. And we'll talk about that because when you start memory swapping on the machine, or what we call thrashing, We want to not have that ability. We don't want to thrash because then something's really going on with the hard drive, and then there may be possible failure getting ready to occur. So limit disk space used to improve the performance of diagnostic tools and backup imaging. So by default, you should be following NIST standards, and those NIST standards actually tell you to partition your system out with /temp /var temp, create everything on separate partitions, because you don't want the corruption, and that's what they're talking about here when we're talking about that. Then they get into this with the master boot record. Partitioning scheme has dictated how disks are partitioned on the system, on systems running the BIOS firmware. The scheme supports a maximum of 4 primary partitions. So you can see here 1, 2, 3, 4. And if I went over here and I did, I'm gonna clear this, and I'll do a F disk minus L again. Oops. And I can see that my disk is /dev SDA. Now I want you to notice some differences. This is SDA, SCSI device, right? This is a actual physical SCSI device. And if you notice over here, I have V for a virtual device. I wanted you to notice those differences. This is SDA, this is VDB or VDA, right? When we're talking about the actual type of device that you're using. All right, so now I'm going to clear my screen. I'm going to do a F disk /dev SDA. Oops, I don't know why it keeps popping up. And then I'm going to do a P for printing. And I want to, when I do a P for print, I want to see what partitions that I have. And if you're not sure what each command does, you can type M and it'll go through and tell you what is what, right? So I'm gonna do a Q for quit, because in the class they use parted. So we're gonna use parted, and I want you to do a -- help, because I want you to see all of the commands. Let me make that a little bigger, and then I'll clear it again. And then we'll do a parted -- help. Let me pipe that over to less so it don't scroll off the screen. All right, you can see here, I could do a parted -L to list out the partition and all the block devices. I can do a -S to never give me anything. And then -M displays the machine possible output. So now I want to do a parted -L because I want to just give me a list. All right, so now I can do, oh, and let's go back. One thing you need to look at. You do a parted -L and then the device. You get, and I'm getting that from here, how the command is laid out. How do you use the command? I do parted, and these are what we call options here, and they have the options listed here, right? And then the actual device. In this case, I'm doing SDA, right? So let's quit, and let's do parted -L and /dev SDA. And so it gives me the FAT file system and XFS, and it tells me it's using partition table GPT, and it also gives me a disk size, and it tells me too that it's Google persistent disk, right? So the first time I used fdisk, I was just showing you how you can use fdisk, and then the next time I used parted. There is a difference between fdisk and parted. They don't talk about it in this class, so let's go look that up. Fdisk versus parted. Let's look and see what we have here. Let's see if they give us a clean So no, okay. If this defaults to cylinders, is useless. No hard drive has used CHS in almost 20 years. Cylinders, just that. Another parted default is compact. Reporting mode is equally frustrating. Blah 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 blah. Uh, Starting parted in sector mode uses units or unit S options, gets around, blah blah blah. That's not a good description. Let's go back. Let's find. Let's see if we can find a, a key difference here. Let's see that makes sense to you. And they show me that, and they show me that I can use parted and L this. What they do, what right here, what they're showing is initializing a raw this device. I can only use fdisk, and this is Oracle based right here. Oracle uses the raw disk when it's creating its clusters and creating new partitions with fdisk and parted. And then they showed the current partition table, which we just did with fdisk shows cylinders and sectors, whereas parted shows sectors and megabytes. And to delete partitions, you can do that with fdisk and parted, but you can't change the file system type with parted, only with fdisk, and make a bootable partition, make a partition bootable. You can only do that with fdisk. That's what they're showing here. But it didn't tell me like the differences. And, I mean, I see the differences, but why should you care? It's more or less in lines what I'm looking for there. Any questions while I'm researching this? Not that you really, if somebody's gonna quiz you on it. I've never known nobody to quiz you on like what's the difference between FDisk and parted. All they want to know is, do you know the difference between EXT3, EXT3, EXT4, exit and XFS, and how can you create a partition? That's usually what most people want to know. So you don't really have to worry about this per se. I just want to see if I can find it. I'll probably find it later on and then post it. I don't want to hold up the class looking for it. All right. So here on Linux systems, you can use extended partitions or logical partitions. Administrators can create up to 15 partitions. I mean, like 15, you know, little partitions on a disk. We're not talking about LVM right now. We're just talking about partition. All right. And it says because the partition size data is stored in 32 bit values, this partition with the NBR scheme have a maximum disk size of 2 terabytes. And that is really one of the limiting factors, because as we were in computing, as the disks were getting bigger, there were limitations to which tools you could use, and that may be why one of the major F disks between parted and F disk was the sizing of the disk. Right. Because the physical disks are getting larger, the SAN-based volumes are larger than 2 terabytes. The disk and partition size limit of the master boot record scheme is no longer a theoretical limit, but rather than real world problems. So then they get into talking about, as a result, the legacy MBR scheme is in the process of being superseded by the new GUID or GPT for disk partitioning. And so then they get into now this right here, if you're on a physical machine, you'll start getting into UEFI firmware for security purposes and so forth. GPT is the standard for laying out partition tables on the physical disk, and GPT is part of the UEFI standard. If you ever ordered a business desktop and you install an operating system, you'll get into the UEFI, how to secure, do you want to do that? And I think when I was doing my VMware stuff, we got into that. Let me look here. Let me just do a new one so you can see exactly what I was talking about. And then you hit continue, and let's go and hop down here and do rel 8 and hit continue. You can see I can use legacy or UFEI and then or secure boot, right? And if I wanted that particular instance to have UEFI, so you get that option in VMware Fusion, right? All right, so now let's go back over here. All right, GPT has a maximum partitions of 128 partitions. Before, remember, we had a max of 15 partitions. Now we get 128. Unlike MBR, which uses 32-bits for storing logical block addresses, this is not interview questions. I'm just bear with this information. GPT allocates 64 bits for logical block addressing. Now, it does matter. This will help you when you're just trying to decide on partitions, but if you're in the cloud and so forth, you could care less about partition. This is more geared towards people who are probably on-prem using stuff like this. It says GPT is this allows GPT to accommodate partition disk up to 8 zettabytes. Hold on, is it ZB bytes? ZB bytes or 8 billion TB bytes. I've never used that much data. I don't know. I've never used that much data, but here you go. There are actual entities you can only think like the Library of Congress and NASA and anything dealing with the Department of Labor, the VA. You can only imagine the amount of data that they use and how they're using that data. Any questions so far? Before we continue on, just making sure we cover everything. No, all right, cool. All right, GPT provides no, we did that. In addition to addressing, okay, yeah. In addition to addressing the limitations of the MBR partitioning scheme, a GPT also offers some additional features, and so they're talking about the GUID. And we get that. Well, we get a UUID when we look at it. That's not where I want to be. When we do LSBOK. And what is it? What is it that you get from the UID? Is it LSBOK? I'll go back and double check it. I forget the command. To identify each disk, in contrast to the MBR doesn't do that. And the primary GPT resides at the head of the disk, while a backup copy, the secondary GPT, is housed at the end of the disk. And so they're showing that here and here in between the partitions, and then this is just space unused. And it's on a virtual disk B, that they're showing that these different partitions are, and you can see they're different sizes as well too. And so they talk about is it dash FP? Let's go back. Yep, there's your UUID. There's another way to get UUID though. It's not LS block, it's something else. There's another way to get UUID. Hold on. I forget what it is off the top of my head, and I use it all the time. Let's see, it's LS block. Oh yeah, block ID. That's what it is. I knew it was another one. There you go. Gives you the block ID. Right. So let's get back. All right. So now managing partitions with parted. All right. So we just got through talking about the differences between FDisk and parted. And here they want to show you they did a parted and then they did a print on the end. Remember, let's go back and look at, we can go into the class. They just got a host here. So I have a screen up here. Let me sudo -I. They do that in the class as well too. When you type in the password, let me clear. All right, they may be a little small, but you should be able to create your class and actually follow along here. I want to do a parted dash help, and here they gave the print command. So at the end of that, so see it says it's a command, right? So you could do parted and then your option. And if you're not sure where I'm looking at, let me get my tool. Let me see. Is it gonna let me do it? Right there. Oops. I suck at drawing there. That's where I'm at. That's what I'm reading. All right. So I can do parted and then my option and then the device and then the command. So the command print comes afterwards, where it's going to display the partition table, available devices, free space, all found partitions on a particular partition, right? So let me go and clear that. All right. And then let me get my pointer back and then let's clear my screen. And then for the sake of argument, let's do a df minus h. We have a V in this case. We have VDA2 and VDA3. So what we're going to type is parted / dev VDA print. All right. So we're going to do parted / dev VDA because that's the actual device that we have, a virtual device, and then print. Oops. I think I got I got a character in there. Let me get that character out of there. All right. So now when I do that, when I run that command, it's giving me, the file system of FAT16 and XFS. And it also gives me the start and the end blocks of that and the number of partitions. You can see 1, 2, and 3 there, right? So if we go back over here, they don't list out what each one of these mean, but this is the file system type, which is XFS. This has some boot flags, I mean, it's probably booting off of that. This is the type of partition. Remember, you can have primary or logical. Here is the size, and here is the start and the end. This is the size, and this is the size, and then it starts at 10.7 gigabytes and then go to 53.7 gigabytes, but it's 42.9 gigabytes in size. So don't let this number right here, I don't want you to think the end matches up with what the size is. Remember, this is where they started at and ended at for the first partition. So that will more than likely be the same, but where they start and end for this particular partition is not going to be the same as the end for that. They're two different numbers, and there's a reason for it. It's the sizing of that, right? All right, now there's like, well, run parted / dev VDA. And when you get in here, type print. Well, we did that up here all in one step. And in here, they're just showing you what that would look like. I'm not gonna run that command because I think you get the gist of that. It says if you do not provide a sub command, part it opens up in an interactive section. So we just pass the command. If we don't pass the command, then we drop into parted and then we type print, which gives us the same information, but we just passed it all in one command, right? So it says by default, parted displays all sizes. Now, if you notice that kilobytes, megabytes, and gigabytes, and here's a note on this. There's a difference between KIB, MIB, and GIB. And you'll start to see that as you progress in your career, but I want you to know there's a difference between the two, and they'll get listed out. And what I'm talking about is difference between GIB versus GB. All right. There's a difference between that notation. And they go on to talk about it here. I'll drop you this link. Maybe confusing, but there's going to be a time where I can't drop this link. I'll drop it in the RHC study group. There's going to come a time where you're going to need to know that difference when you're playing around with stuff. All right. So then let's get back to the class. And they actually talk about it right here too. All right, so S for sector, B for byte, and then MIB, GIB, TIB are in powers of 2, and then MB, GB, TB are in powers of 10, right? So you have to recognize that when you're doing your sizing. All right, so parted/dev command, and we're sending commands, command unit S print. So if I didn't do that, if we didn't run that right here, you would drop down into parted, you would type in unit, you would type in S, and you would type in print. So in here, it says, as shown in the example above, you can specify multiple subcommands. Here's unit, and here's print, all on the same line. And we're showing that S is for sector, remember, and then unit, and you're getting that information. Now it says writing the partition table on a new disk. To partition a new drive, you first have to write a disk label to it. The disk label indicates the partitioning schema. Keep in mind that parted makes changes immediately. So if and here's the difference between, I guess, parted and F disk too. When you use parted, you say parted/dev VDB, make me a label MS-DOS, it's immediately, versus you use fdisk, you have to hit the W command to write to the actual disk. So it gives you it's a little bit more lenient when we're talking about it. To write a disk label, use the following command, parted /dev VDB, make label GP. And it talks about what the make label is. The make label subcommand wipes the existing partition. Only use make label when the intent is to reuse the disk without regard to the existing data. If a new label changes the partition boundaries, all the data in the existing file systems will become inaccessible. So let me give you a quick story. I had a lady come to me. This was back when I was working at SAIC, and she came to me and she said, "Hey, I need help with getting this data off this disk and then upload it to here." I said, "Okay." I said, "I'll try to help you." I said, "But I don't want any parts of this," because I knew who was working on the project, and I just didn't want any parts of it. So I said, "Do you care that this stuff that's on this disk gets wiped?" She was like, "No, I don't care." I was like, "Are you sure?" I said, "Do you want to back up the disk first?" She was like, "Nope, I don't want to back up the disk." I said, "Are you sure?" She's like, "Yes, I'm sure." I was like, "I think you should back up the disk first and then come back to me." Right? But the disk was 100 terabytes and it was sent from somewhere else. And she was like, "Yeah, I don't have time for that. This need to be done tomorrow. I'm not going to back up this disk." So rule of thumb, always back up files that you're going to change. Always create a backup with them, and any disk that you're going to upload or copy stuff on, back it up first. That's just a rule of thumb I use. So in case something ever happens to it, I can get the data and put it back on there. So I'm good to go. So she's like, "Let's wipe the disk." So I wiped the disk. I told her, I was like, "Here you go. Here's the commands to wipe that disk." I said, "You're going to type them, not me." She typed them in. And the disk got wiped. And then she was like, "So where's the data at?" I was like, "You said wipe the disk. I gave you the commands to wipe the disk." And so she was like, "No, that's not what you stated." I said, "Yes, it is." So it became an argument. And I was like, "I'm not going to sit here with this because I told you what you need to do and you didn't want to do that." Needless to say, she ended up losing her job. And I felt bad, but I didn't feel bad because I gave her the steps that she needed to do in order to get that done. So that's a true story. All right, so here we are. So here, always back up your data first, even if you have to rsync it somewhere or what have you, back up your data first. All right, so here we're doing parted slash dev VDB, and now we're gonna make a partition. That's what basically make part means, make a partition. Remember, we can make two types of partitions, primary or extended. I mean, primary or logical, yeah. But primary and extended, when you don't have any partitions on there, you want to do primary first. Um, and they talk about, they give you a note here. Create 3 primary partitions and 1 extended. That's just logical stuff here that they're going over. And then here, remember when I said that you can have different file system types. XFS is the latest and greatest, and then ext4 or ext4. XFS is what you want to use. That's the default, the de facto standard for Red Hat. So you'll use XFS when you do it. And then here they just talking about, well, I'm gonna pass a command. I want to do parted dev VDB, but I'm gonna send the help command on make part, and that's what they did here, and that's why you got this output here. And then they said, what do you want to start at? What sectors do you want to start at? Well, remember, they got S in sectors, and if you scroll back up here to the top, there's like S stand for sectors, right? And so it gives you the sectors, and you can use MIB, GIB, TIB, MB, GB. Easiest for you to use is MB and GB. All right. And let's see. If you do not provide a suffix, MB is used. So it's going to do megabytes versus gigabytes when it's making its partitions. And then you want to end at 100 megabytes. So the size is the end minus the start. That's how you know what size it is. With parted, you cannot directly provide the size of your partition, but you can quickly compute it using this formula. What the ending is and the start. It's interesting, this is in sectors and this is in megabytes. All right. And then and I'm assuming you would say this is 0 probably, and it's probably just 1,000 megabytes, which is almost a gig, right? So as soon as you provide the end position, part updates the partition table on the disk with the new partition, and then you quit. And then here they said this command udev admin settle. This command waits for the system to detect the new partition and create the associate device under /dev. It only returns when it is done. So it'll go out and it'll probably hang for a while and then return. And then now when you come here, an alternative way, instead of being interactive, is do all of this on one line. And that's what they're showing you there. Now we're gonna create, this is a typo, the GTP, I think it's supposed to be GPT scheme. Also, and if you feel fancy and free, you could probably get in touch with Red Hat and let them know you found a bug in their documentation as you're reading this. Probably be some points for that. Scheme uses parted command to create new partitions. Specify the disk device. So we got parted, and then we got dev VDB. We want to make a part, and we're going to give the partition name, which is user data. We're going to give the type, which is XFS, the sector we want to start in at, and then where we want to end, and then they quit. And then you do the udev settle again, or you can use the one command line, one command on the command line. And then if you want to delete the partitions, you can hop into parted, you can do print. And there, in order to delete in parted is RM. Inside of fdisk is delete. And then you specify the partition you want to delete. And now for the last but not least, once you create your partitions, you need to give it a file system. And so here's the make file system on /dev, and that first partition that you created, or the second or the third or the fourth. and then go from there. And now the next thing you do, you have to mount the system, right? And so now we mount slash dev to a mount point. Slash MNT is created already by default, but you can make that slash TNM or slash data or slash new disk or what have you. You could put that there. And then here they grep VDB to tell you about it's mounted, the type of file system, and these are the instead of probably mounted with defaults, and these are the defaults that get passed along. And here, if you want it to be mounted persistently, remember I showed you FS tab before. You open up FS tab and you can have that set up to load this by your UUID, which is what I was showing you earlier. The UUID changes after you create, like if you got a disk and it doesn't have a partition, it'll have one UUID. When you go to create the partition, and when you create the partition and you add a file system to it, it'll be a whole new UUID. That last UUID is what you want to use. All right. And then here you can see they have it set up by UUID. Like I said, you can get any mount point, defaults, and then 00. Right. It says when you add or remove an entry to FS tab, you can just run system daemon reload. I use mount -RAV because it rereads this particular the FS tab file, remounts it. Whatever you feel you want to use, they just use system daemon reload. The first field specifies the device they're talking about here. The second field specifies where to mount that to, the file system, and then your defaults. And that's what they're showing here. And that's what they're discussing. Here is where you can get the UUID. Use the ls block -fs command to scan the block devices connected to the machine. Keyword here, connected to the machine. So ls block --fs gives you that. Block ID gave you the same thing too. And then they talk about what each one of these fields mean. We can go down this list here. This means I'm on device VDA, virtual device A. I have a partition of VDA1. I have a file system, and here is my UUID and where it is mounted to. And they have that labeled here, the name, the file system type, the label, the UUID, and the mount point. Same here is the actual device, the partition, the file system type, the actual UUID, and then the mount point. And that's what this particular information right here talks about. The other piece that they talk about here is the fourth field, which is the comma list of separated options that display the defaults. And that's what this was up here. What was that at? Right here. When we did a grep, this is what that defaults actually comes out to be. These are things that you can, or options that you can set on defaults in a comma separated list. And that's what they're talking about. Then you jump down here to the fifth block. They say this is the dump command. All right, so back in the day, we would dump data to tape. And it was set up like other, like here it says dump command to back up the device. Also, journaling as well too. So after so many reboots, the system would actually do a correction of itself. Like, hey, I'm basically I'm not in alignment. I'm gonna correct myself and get in alignment, and that helps with the performance of the disk and the read and write of that disk as well too. So this is that dump command that they're talking about. The last one is what they're talking about here. These two fields right here. Right, that's what that comes from. It says right the dump, and then the last field or FCK, the order field, determines if FSCK command should be run at the system boot to verify the system is clean. And that's what I was talking about. It's either set to 0 or 1. For ext file system, set it to 1 for the root file system, and for the root file system, and 2 for the other ext4 file systems, right? You notice they didn't say anything about XFS, right? And then they got notes, and then they have good old handy dandy resource documentation where you can go and start diving into file systems and how they work and a little bit more information. So let's go back because I think it took me out of the class. All right. So now let's go managing basic file system. So for you, you would run this command on workstation. So if you are in the lab, you go up to lab environment. You would click on workstation and hit a console. The console will open up. Hit enter, enter again, and type in the password of student. All right, when it comes up, it should give me a screen, but if it doesn't, there's a little thing up here in the top corner that says activities. We're about to find out. You want to close this because you're not registering the system. And you come up here to activities, and then you click on terminal. Once you click on terminal, now you're in the actual terminal. Once you get there, if we go back to the lab, we're in 6. Yeah, just drop this back in there. You want to type lab storage status review start. And it says new disks are available on server B. On the first new disk, create a 2 gigabyte GPT partition named backup. Remember, you can run this all in one command. All right, because it may be difficult to set the exact size of 1.8 gigs to 2.2 gigs is acceptable. 1.8 and 2.2 gigs is acceptable. Set the correct file system type to be XFS. So what would that command look like? And you need to be root when you do this. I'm not going to show the solution. I want you to type in the comments what that command would be like. What would be like? What would the command be? Right? So we want to use parted, or no, or do we want to use GPT? So let's go back to our lab, right? Let's go back 1. And let's look at where they did that command at. Because you can do a label. So let's go back. Let's figure out that command. Is this it? Am I on the wrong one? I am. Let's go here. I'm on the wrong one again. Right here. Come on. All right. Parted. 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 All right. That's more parted. More parted. And we made the file system. Okay. So your command could look like this, right? Could look like that. Parted. And I need to bring this up in 2 terminals. We'll parted the device, make a partition. You don't have to do primary. Yeah, you may have to do a label. You need to do a label. I'm gonna look up here. I'm gonna look up GPT here. Because I am missing one thing from memory. All right, here we go. Parted/dev, you want to make the label of GPT. Let's go back to the command. Well, let's go back to what they want us to do. All right. So we hit next. Did I miss one? I guess I did.
You were in the review just then when you were reading.
Oh, that's what it was?
Yeah.
Well, that's even better. But that's all right. All right, so I did skip one. All right, so guided exercise. All right, so here's the exercise. You're gonna do a lab storage partition. Start. You're gonna run that command. From the workstation, it's telling you you can SSH or you can just do like I did, open up the console. I showed you the sudo -I for and type in student. And here we go. Make the label of use parted to create a new label of type of MS-DOS on /dev VDB. You can see if I cut this off right here, just block that out. If I did parted /dev VDB, then I would have to type make label and then uh, uh, MS-DOS, right? But here they're giving it to you all in one command. You may need to update fstab because in fstab it may be something else, right? So you may need to go in there and change that. That's what that's revealing to you. All right, here they already have some partitions out there or some drives out there. And they're saying for proper alignment, start to position at sector 2048, and then set the partition type to be XFS. So here they did parted with VDB, and then you make a partition again. It's going to ask you these questions: primary, XFS, the sector you want to start at. Excuse me. And they said of 1 GB. Well, you could do 1,000. You could do 1 GB or 1,001 MB, right? And then quit. And then because the partition starts at sector 2048, the previous command sets the end position to be 1001 to get a partition size of 1 GB, right? And then they give you an alternative. This command, you can do it all on one line, make the partition primary. Remember, the command, the device, I mean, not, the, well, let me say this, parted or the command, the device, the commands within parted that you want to use. And then primary, basically answering the questions all on one line. And then you can do the print here where it's going to print out everything. Settle, it's going to take a minute for everything to get done and return. We still have one more step. We created a partition, but we haven't given it a file system. You're going to give it a file system, and then you're going to tell it where to mount to, and then you're going to find out what the UUID is, and then you're going to add that to fstab, and you're going to tell it where to mount to over time. I mean, over persistent boots. And then you're gonna say, you know you did it with XFS in terms of the file system type defaults, and then remember we're gonna set this to 00. And then you do a system reload, daemon reload here, and then they do a mount slash archive. This is why I do a mount dash RAV, because it's gonna read slash etc fstab, and I don't have to do this step right here. It's gonna mount what's in there, and if it fails, I'll know immediately, and I won't have to worry about rebooting my system. Here, if I fat fingered something, I don't know if I fat fingered everything in there or whatnot. If I made it, put a character on another line, I won't know that. So that's why I do the mount dash RAV, because I'll get that immediately if I fat fingered something. And then here it just grep, they're running a grep and so forth. And now you're gonna reboot and you're gonna check to see if archive is actually come back to you as a mounted partition or a mounted directory at this point. A partition mounted to a directory. And then you're done. And then it says when done, log off from server A. You're gonna reboot. Then you're gonna go back to it, and then you're gonna grep to see if it actually got mounted, and then you exit. And then don't forget to run lab storage finish, and then it's gonna reset all the machines in that particular uh uh in the particular section. So it's gonna reset probably server A for you, so you don't have to reset it yourself. And then our next one is managing swap space. But let me double verify some questions. What command What was the command you entered? Oh, it would be this command here. Let me clear my screen. Mount dash RAV, right? Because if let's say if I went into FS tab, right? And let's just let's VI etc. See, there's that tick there. FS tab. That's my fingers. And let's just let's do this. And what I want to do is I want to get rid of some characters here. I'll add a character. And we'll put this on archive. Put it on arc. And then I'll save it. And I'll make a directory called arc. Right, so that's clear. Oops. Okay, cat phone. All right, so now let's do an ls. I mean, not an ls, but a tf minus h. And then I want to do ls on slash. So I made a directory called arc, and I wanted to also cat fs tab. Oops, tab. All right, so what I did, I just copied this and put in an extra character just so it could screw up something. All right, and now when I do a mount dash RAV, it's gonna tell me it can't mount art can't find this UUID because I know it doesn't exist because I put a fake character in there. Like, but I immediately know now that when I reboot and it's gonna try to mount that, I'm not gonna do that. I'm not gonna get that. Let's see if system daemon reload actually gives us that error. Nah, it don't. Let me see. Let's do a tail dash in 5 on var log messages. I can do journal too. Let's see, journal control dash xe. Yeah, see, it don't tell me immediately that I love the hackers. It doesn't tell me immediately that something's wrong with that file. So if I do a mount dash RAV, I immediately know something wrong with that file, and then I can go in here and correct it. Right? So now I can just use my up arrow and get back to the Vim, and then I can just delete this or correct the error. In this case, I'm deleting. And that way I immediately know that, oh, okay, yeah, we're cool now. All right. And it's whatever I needed mounted will be mounted. All right. All right. So now we're hopping into swap. I didn't get a chance to go through all my stuff. I'm sad. All right, managing swap space. All right, after completing this session, you should be able to create and manage swap spaces to supplement physical memory. Physical memory meaning that my machine is running out of memory, but I have 2 gigs, but I have a 2 terabyte storage drive that I can use swap space on to continue to crunch numbers or whatever it is that I need to do. So I can use, and in some instances, if you have a SAN storage, people will allocate those faster disks in terms of being able to use as cache or as memory to run in-memory commands or something of that nature. They'll use that. But in this case, we want to do a swap space in this area. It says the swap space is an area this under control of the Linux kernel memory management. Now we talked about the kernel some and memory management, but we didn't go into detail about this. But again, gets into us understanding embedded systems and managing jobs and tuning the system. And we talked about that before in some other classes or in some other meetups. All right, so the kernel uses swap space to supplement the system RAM by holding inactive pages out of memory. The combined system RAM plus swap is called virtual memory. And you can find out how much virtual memory you have with top. And if you're in the 124 class, you are probably playing around with top and different commands and so forth, right? When the memory usage of a system exceeds a defined limit, the kernel reaches through RAM looking for idle memory pages. And let me give you a visual what memory, let's see, let's do computer memory looks like. I don't know if you've ever seen it before. And that's not what I want. Let me see. You may have to go to a class. That's pretty close to what I want. Yeah. All right. So virtual memory and physical memory. And they tell you like how they line up, where the disk come from, reading from the disk, reading from RAM with the physical memory. And there's another page out here that actually goes over and breaks down like what each one of these sections are. So let's look up virtual memory operating systems. Let's see, do they have that there? And you're like, this is useless information. It actually isn't. This actually helps you inside your CRE information. So that looks a little better. All right. So when they were talking about pages, they were talking about pages of memory and memory mapping and how memory mapping works. Good class. I wanted us to start reading a book, and I want to start off with operating systems. Here they talk about here, see the diagram showing below is a larger showing virtual memory that is larger than physical memory. And the code, the data, the heap, and then the stack. And we start getting into assembly language and so forth, but I really like for you to understand like how memory works, how kernels interact with the memory, how processes and kernels all interact with each other, and then how to do performance and tuning. Will really help you out in your career, looking at it from that perspective. All right, so then here there's like the memory usage of the system exceeds a defined limit. The kernel searches through the RAM looking for idle memory pages. You just saw the pages and assigned to process. The kernel writes the idle pages to swap area and reassigns the RAM pages to the other processes. In other words, this process needs this memory. Let me go ahead and assign you that. Remember, we started talking about the scheduler and so forth, or when we're talking about with Linux. If the program requires access to a page on the disk, the kernel locates another idle page of memory, writes it to this, then recalls the needed page from the area. And a lot of times we don't want to get into this in terms of you starting to use your disk for memory. Because swap areas reside on this, swap is slow when compared to the RAM. And while it's used to augment the system RAM, you should not consider swap as a sustainable solution for insufficient RAM for your workload. There you have it. All right, sizing the swap space, 2 GB or less, twice the RAM, 3 times the RAM, 2 GB to between 8 gigs, same as the RAM, twice the RAM. And they're just talking about the sizing that you want to create for your swap space. All right, I won't read everything, but they like create swap space, creating a swap partition, and guess what we're back to? Using parted. All right, so on VDB, we're gonna make a partition right here, and we're gonna name the partition. We're gonna choose a file system type. This time we're using Linux-swap as our file system type. And then we're gonna start, notice that we're not using sectors anymore, we're using sizing. We wanna start at 1001 megabytes to 1257 megabytes, right? And then print that, remember parted is immediate, so it changes immediately. All right, and then they print it out, and then you do your settle again, and now you have to make your swap on the partition that you picked. All right, you did this partition, it already had a partition of one partition on there. You made another partition, so now you have 2 partitions. And so on the second partition is where you're gonna make your swap. And now you need to activate it with the swap on command. And then you can do swap -A to activate all the swap spaces, or swap on. It showed to see what you have right here, swap on /dev VDB2 or free. And now when you go do free again, you'll see that the swap came up right here. When we did free, we didn't see that. When we activated swap free and then free again, the random command free, it came, you saw that the additional swap space. You can deactivate it with swap off. Now, if you want to make it persistent, remember we've already created we already set it up with the particular file system type, and that's really not a good way to say that for this particular one, but it is keeping in line with what we've been talking about. And then now we have that UUID, and then we need to add it to FS tab, and that's what they're showing here. And then once we do that, again, you'll do the system daemon reload right here, or the mount-rab. And here it says you want to set priority for the space. So basically here they're saying when the space is full, it uses the second entry. Oh, hold on, right here. The kernel uses uses the last entry first. So it's going to use this a priority 10 first. When that space is full, in other words, you're filling up hard drive space. When that space is full, it will go to the second entry, which is a 4. So the larger the number, the higher the priority. The smaller the number, the least the priority. It says the kernel uses the swap space with the highest priority. The default is of -2. Right? And then they just do a swap on. Again, always read the knowledge space and so forth. And then that's it for that one. And then they get into a guided exercise on how to do swap. And I won't go through that because you can do it. All right, and now here is a lab on everything. It's an overview of setting up the partitions and then doing swap and so forth, and then we're done. So that is all of chapter 12 and 6. There's a summary of that. All right, and then chapter 7, managing LVM. So before I dive off into this, what are your thoughts? How you feeling? Can you keep pushing? If you got to drop off, I understand. Any thoughts? Okay, everybody's good to go. All right, so LVM, logical volume management, right? This is probably gonna be what you use all the time if you install Red Hat by default. The way they break it down is there's the actual physical device, meaning the actual hard drive itself. And then when you do a PV create, it looks for the physical device to create a physical volume. And then you'll do VG create to create a volume group, and then a logical volume to create a little small snippets of that big volume group, right? And in here they break down physical and volume and logical volume. Let me give you a picture of it. Let me back out of this. Again, the physical drive, right? That's what they're showing here. And then here you're going to put that into a physical volume group, which is your PV. And then, I mean, physical volume, and then you're going to put this into a volume group. And as you can see, they're taking all of these hard drives and putting it into one volume group. And then because I have this big, say this is 10 terabytes here, or say this is 5 terabytes or whatever, I'm then going to do a logical volume and chop this up into slash data slash utils slash docs slash programs. So these are logical volumes that are created all the way from this volume group here. And that's what they're showing you there. All right. Here, it says the examples use device VDB and its partitions to illustrate LVM commands. In practice, these examples would need to use the correct devices for this and this partitions. Use the ls block, the block ID or cat partitions command to identify devices on your systems. These commands are important to you and you should get familiar with them. You will be using those. So as you can see down here, they're using parted again to create a VDB, to create a partition. Remember with the dash S what we're doing here, and making a partition of primary from 1 to 769 megabytes. Then we're gonna make another primary partition from 770 MIB to 1026 MIB. And notice they're using MIB versus MB, right? Or GB. And then they're gonna set on the first partition LVM on and LVM on those two partitions. And that's what they're showing you here, right? And now, because we have those partitions, now we can do a PV create on VDB2 and VDB1 the same way up here where they're showing dev SDB and dev SDC. They're not partitioned, but they're already partitioned down here. So they're doing that on, instead of a whole physical device, they're doing it on partitions of it, right? And they've already been sized. We sized them back up here. All right, now these labeled devices slash dev VDB2 and VDB1 as physical volumes are ready to be allocated to the volume group. We just did the physical, the PV create. Now we're going to create the volume group and we're going to name it. So it goes VG create, the name of the volume group, and the two physical volumes that we're throwing in there, or the one physical volume that you want to put in there. And then here it says this creates the volume group VG01 that is a combined size of PE units of 2 with VDB2 and VDB1. And then they go on to say the VG only needs to be created if none exist already. Additional VGs can be created, volume groups can be created for administrative purposes, reasons, and so forth, right? So then next one, we're going to create a logical volume. If we go back up to our diagram, remember we get a physical volume, and then a volume group, and then now we're going to do a logical volume. We're going to chop that up into smaller pieces, right? We can have multiple volume groups. We can have multiple physical volumes. We could did one physical volume for and a volume group and a logical volume for one disk. We can chop that up how we want to. All right, so now jumping down here to LV create. you need to look at what these options mean. You can use the man pages or help. Let's go here. When I say that, I can say man LV create, right? I can do a man on that. I can also do LV create dash dash help, right? Okay. Get familiar and understand the command line because it's going to help you on your test. So with LV create, we have options, right? So this dash N is naming the logical volume. The dash L is giving you right here is the dash L is the LV size in bytes. Key word here in bytes, right? So here we got the big M, right? And it says right here, this creates a logical volume LV01 of 700 megabytes. Remember, powers of 2 and powers of 10 in size, and a volume group in the volume group VGO1. So we have to have the volume group first. It is physical, volume, logical. Physical, volume, logical. Physical, volume, logical. What comes first? Type it. Type that for me. Let me see if you got it. Physical, volume, logical. All right. You go physical. You have to have something physically first, right? I can't chop up nothing I don't have, right? So I have to have a physical a device. And then I create my volume group. And then I create my logical. Physical, what did I say? Physical, volume, logical. Right. All right. So here, you can specify the dash L option, which is specs in sizes of bytes, megabytes, binary megabytes. For all sakes purposes, just use capital G. Don't get caught up in on the test on GIB, MIB, if they ask for it, right? But just try to make sure you use the big G, big M in order to keep it simple for yourselves. All right. So here they say this list provides some examples of logical volumes. LV create dash L128M is size is the logical volume to exactly 128 MB, right? And then LV create dash L, look at the lowercase here, creates using exactly extents. So you need to understand the extents, right? Lowercase L goes with the extents, and you can find all this inside of the man pages or the help. You don't have to try to memorize this, right? It says the total number of bytes depends on the size of the physical extent block on the underlying physical volume. And they're actually talking about the underlying physical machine, that device, right? All right, so we got through that. Now, once we got everything, we need to do what we always been doing, is create a file system. So we're gonna create that file system there, and they're showing you the path, right? The path is /dev. All devices go under /dev. Yep, yep. And it's funny they don't even go through that in here. So /dev, the volume group, and then the logical volume. And here, this dash T, you're specifying the actual file system type, right? And then, of course, last but not least, we need to give it a place to mount, and we need to update FS tab. But look at here. Remember, they got that one and that two turned on, right? And we talked about that in the last one. Right? And then they do a mount dash MNT data, or you can do a mount dash RAV, right? And then they, let's say at the end of this, remove everything, unmount it. To remove your logical, again, when you see that LV, there should be logical volume. That should automatically pop in your head. LV, remove this, not the path, but we're removing the logical volume. And then you can't remove the volume group without removing the logical volume. And that's it. You might can do that, but I don't think you can. I think you have to remove it first. I think you can force it with the volume group to remove it, but I think the order is the way you created it, physical, volume, logical. Now you do the opposite to remove it. You do logical, volume, physical. So now you're going to remove the logical volume, you're going to remove the volume group, and then you're going to remove the physical, right? And then they go in here to show you different commands to review the status, which is PV display. And they break down what each one of these mean. The PV name, the physical volume. Remember, we made a partition on it, so /del VDB. The volume group number 2. Number 3, the actual size. Number 4, it tells you the PE size is the physical extent size, which is the smallest size of a logical volume that can be allocated. And they talk about that for number 4 right here. And number 5 is your total PE physical extents, and then your free physical extents, and then your allocated, and then your physical volume UUID. And it's get down in here. It says the PE size, which is the smallest size of the larger one, could be allocated. It is also the multiplying factor when calculating the size of the value reported in PE units, such as free PE, for example, 26 PEs times 4 megabytes is the PE size equals to 104. So that is where it gives you at to how it got calculated there. And a logical volume size is rounded to a factor of PE units. So that's how you calculate it. And then they go to show you, if you want to see what the status is of the volume groups, you can do VG display, and they go and break down what each one of these mean. The name, here they show you, is it read or write? Is it resizable? Can you resize this? That's set to true or false. Your total PE size, your VG size, and your free physical extents, right? And they break it down. And then now LV, again, LV display, you're doing logical volume, and they break down each one, the path, the name of the logical volume, the name of the volume group, the size, the current LE. What's LE? Current LE shows the number of logical extents used by LV. And LE usually matches to the physical extent in the VG, and therefore the physical volume. So they break that down there too. Another one is here, the time, right? Creation, host, and time. And then that's it. And then they give you a guided exercise to walk through to do this lab. And then the next one is extending the logical volume, the volume group. And I wanted to point out here before we get started, XFS goes with if you make the file system XFS. If you're using ext4, it goes with resize 2FS when you're doing when you're using ext4. So they talk about extending the volume group, and what does that look like? So you created a volume group, now you want to extend it. And let me see what else is next in this chapter. A guided exercise, and then managing logical volumes. All right, so I can knock this out in 4 minutes. You with me? You should be. All right, so let's go back. All right, so extend the volume group with PV create and VG extend, and use VG display to verify the results. You can reduce a volume group using the PV move and the VG reduce. And then you can say extend a logical volume using LV extend. And then I just talked about XFS grow FS and resize 2FS. All right, so extending and reducing a volume group. When does this happen? Well, it happens when you extended, say you were working with some people and you gave them, let's say you gave them 200 gigs and they're only using 10 gigs in a volume group or what have you. And it also depends on a couple other things. But for now, let's say you gave them too much and you want to say, well, I don't want to take everything for them. Let's leave them about 40 gigs. They're only using 8 just in case they grow or they need it or may need to grow it. I'm gonna take 60 gigs and give it to something else. This is what that was created for. So you can add more disk space to a volume group. You can physically add more disk to a volume group, right? This is called extending the volume group. Then you can assign the physical extents from the additional physical volumes to the logical volume. You can remove unused physical volumes from volume groups. This is reducing the volume group. First, use PV move command to move the data from the extents. Remember now, we're handling data. Uh, and extents on the physical volume to extents on other physical volumes in the volume group. In this way, a new disk can be added to an existing volume group. Data can be moved from an older, slower disk to a new disk, an old disk removed from the volume group. And this is important because what they're talking about here is, say you got an old, slower disk or a disk that's being corrupted or whatnot. You want to be able to add a new disk in. It's faster. It's the pretty shiny toy. And so you can now add that in and then, do what you need to do, add it to the volume and then start moving data over, right? All right. So this is what we're getting into. The following examples use VDB and its partitions to illustrate the LVM commands. Remember, and LVM is a package. It's actually LVM2 that gets installed on your Linux boxes in order to have LVM. If you don't have LVM installed, it won't work. So let me do LVM here. See, it's not installed. If you do yum install, and this is on my cloud machine, LVM2, I'll do a -y. Should it run out and grab and install LVM2 for me. But you know what? This system is not set up. It's not pointed to the right thing. I got to fix that. I got to create a new machine. So this is going to fail, but that's okay. I'll show you how to fix that because it's registered and I don't think I assigned a subscription to it. Oh, I did. Awesome. Cool. So here you go. Here's the packages, LVM2. And you can see here device mapper events, LVM2 libraries, and so forth. They all get installed. Boom, done. And now if I type LVM at the command line, I have LVM. I type help. I get a list of actual commands that I can use. Boom. All right, cool. Bye. Done. All right. So now to extend a volume group, perform the following steps. All right, see here we have parted -s. Remember now we're extending, we got a primary 1027 megabytes to 1539 MB. And then we set that partition on LVM on, we're gonna set on 3, we're gonna put LVM on. And now we can use PV create, remember? Physical, volume, logical, right? So now here we want to extend the volume group, right? Because we already have a volume group. So now we need to extend the volume group. So basically we're gonna take that device and put it into volume group 1. Remember the name of what we want to put in there, right? So now it says this extends the volume group, right? But you're not done yet. Verify the new space. So now we use our command. Remember VG for volume group display, LV for LV display, PV for PV display, physical display, volume VG display, display the volume group, LV. They all go together. It's not, don't overthink it. All right, reducing a volume group. To reduce a volume group, perform the following steps. You need to move the physical extents. All right, so here they say PV and they're giving you the layout. So PV move, PV device name, to reallocate physical extents from a physical volume you want to remove to other physical volumes in the volume group. The other physical volumes must have sufficient number of free extents, meaning if you ain't got it, I can't move it. Simple as that. To accommodate this move, this is only possible if there are enough physical extents in the volume group and if all of those come from PVs. So we're going to do a PV move / dev VDB3. And VDB3 comes from up here, right? So we're going to do a PV move. This command moves the physical extents from /dev VDB3 to other PVs with free physical extents in the same volume group. It's in the same volume group. And that volume group that is in VG01. All right, it says before using PV move, do what? Backup data stored on all logical volumes. Yeah, that thing there, that thing backup. Yep. I want to say something else, but I won't. All right, so use VG reduce. And to do that, you got to get the VG name, the volume group name, and then the physical device to remove a physical volume from the group. So here, VG reduce, the actual volume group, and then the device you want to reduce. This removes the device from the physical volume, PV, from the VG01, which is the volume group. And now it can be added to another volume group. Alternatively, PV remove can be used. But here's another thing too. When you reducing, you probably have to get rid of that logical volume, right? Now we want to extend the logical volume, and then this one is using XFS file system. So to extend a logical volume, perform the following steps. View the volume group, and now extend it. So here, LV extend -L. Remember, we had a lowercase l and a capital L. Be mindful of lowercase and capital. 300 megs, and then the entire volume group. The entire path /dev VG01, and then the logical volume. We're extending that by 300 megs. This increases the logical volume by 300 megabytes. Notice the plus sign is in front, which means add this value to an existing size. Otherwise, the value defines the final size of the LV. With the LV create, different methods exist to specify the -L. There you go, physical extents as an argument, and the -L is the capital L. The lowercase l is physical extents. The capital L expects a size. And then they go on to show you different ones here. Physical extents, plus add physical extents to the current size. This one right here resizes the volume group to exactly 128. This one here is resize the volume group to exactly 128. And this says add 120. So you really probably should look at these commands here. The difference here with the plus is adding, without the plus, you're resizing. Adding and then resizing, and then adding 50% of the current free space to the volume group. And you can do that, right? They're showing you that. And now they hop down here and they say, well, if you're using XFS, you use this command to grow. XFS grow /mount /data, and then do a df-h on the mount point. And then here they want to talk about resize the volume group. And they go into the steps in order to extend the to extend the logical volume group of XFS. Here they're showing you LV extend, the lowercase l with the extents, and if you did a capital L with the plus, and then the actual path to the logical volume. That's one thing you're gonna have to remember is the path. And then resize the entire path. And they go on to talk about how can you do this with swap, right? Now, here's the thing. the way they created swap earlier, they didn't create swap in a volume group. Here, the swap has to be in a volume group. It has to be in a volume group first before you can do this. So here they talk about logical volumes formatted as swap space. And what does that look like? So it has to be a logical volume. It can't be just a partition if you're going to extend the partition of it. And then they talk about how do you extend it. And then also here, how to make swap on a logical volume, and activate it and swap on right here. And that's the gist of this. And then they have a guided lab that goes into this. My suggestion is take your time on this one, right? On this extend, because this screws over a lot of people. I would go through this particular one probably 3 times so you can get an understanding of what you're doing with it. All right. And then there's a lab managing logical volumes. Let me see. There's a guided exercise, and then a lab, and then a summary. And that's all our chapters. We went through, finished chapter 12, 6, 7. We didn't get to 8 and 9 like I wanted to, but that's okay. 8 and 9 we can do next week. Well, I really wanted to get through 8, but that's okay. We can do 8 and 9 next week. That's no problem. And then we'll be able to do chapter 10 and 11 together. We may be able to do all 4 of these next week. And we've already completed chapter 12, and the last 2 would be 4 and 5 ACLs and SE Linux. And last but not least is containers. Containers, I think you're gonna get that really quickly. We're gonna fly through that really quickly. I think you'll be fine with containers, but we'll spend some time on it. We're almost done. So today we covered the rest of chapter 12, all of chapter 6, all of chapter 7. We'll knock out 8 and 9 next week. And yeah, so 8 and 9 on Wednesday and 10 and 11 on Thursday. And then the following week, 4 and 5. All right. And then the week after that, chapter 13 will be containers. We'll break that up into a Wednesday, Thursday class. And then all of this is comprehensive. And we're ready to go through and start testing. So that was it. So next week we'll have 2 classes. So next week we'll be knocking out chapter 8 and 9 on Wednesday. On Thursday we'll do 10 and 11 because we meet twice next week. And then the following week we will knock out chapters 4 and chapter 5. And then the following week after that, it'll be chapter 13, which will mean we'll meet twice, which is a Wednesday and Thursday, and we'll do containers. No class tomorrow.